Hello and welcome to More Math. I am Miss Moore and I am so excited to be here again. This is episode 7. We've been going 7 weeks strong and I am so excited because each week I get messages from parents saying how much doing more math really helps their child from acing tests to acing assignments, getting that last minute math grade up as we're coming to the end of the school year. So I'm so excited about what's happening at More Math, and I am back here for another week to help you with your math homework. So if at any point during the show you have math homework, all I need you to do is go ahead in the description of this video. We have a Google form for you to fill out to submit your questions. You can go ahead and submit that form, and then you can make a call, call us, and I will help you on the call, okay? So that's how it's going to work. So I have a first student guest, and as she gets ready, I'm going to start off with integers, just an introductory to integers, and then we're going to bring our first student guest on. So let's do it. What are integers? Okay. So integers are positive numbers, negative numbers, and 0. Remember, 0 is neutral. It is not positive or negative. So if we have a number line, I'm going to draw 0. And on this number line, the numbers on the right go on forever and ever and ever all the way to infinity. So that's why we draw that arrow. And the numbers to the left of 0 go all the way to negative infinity. Yes, that's a thing. Okay. And so we draw an arrow on that side as well. All right. So I'm going to draw probably about 5 on each side. It's not perfect, but it will do. Okay. So if I said graph negative 3. So if I say graph negative 3, what do? Well, you go to negative 3, which is right here, and you're going to put a circle. Okay, so an integer is a negative number. It is a positive number and 0. Okay. Where do we go? And 0. All right. So if I say graph the number 2, we would draw a circle right there to represent the number 2. If I say graph negative 5, we would be here. If I say graph 0, we would be here, right? Super simple, easy peasy, right? All right. So now let's talk about opposites. So we have these integers, these negative and positive numbers. But what's special? There's something special about these opposites. And what do I mean by opposites? I mean like negative 4 and 4, or negative 3 and 3, right? Oops. So that's what I mean by opposite. Now, what makes these opposite? What makes these numbers opposite? So let's start with negative 4 and 4. What makes them opposite? Hopefully, you're able to see that 0 divides them. And if I go to the right of 0, 1, 2, 3, 4 spaces, I get to the number 4. If I go, so if we go right 4, we're at the number 4. If I go left 4 spaces, I'm at -4. Okay, so opposites are the same distance away from 0. Okay, 4 and -4 are opposites because they are on the opposite side of 0. They have the same distance away from 0 on the number line. So if we were doing number 5, what is the opposite of 5? If I go to the right 5 spaces, I'm at 5. Now, if I go to the left 5 spaces, 1, 2, 3, 4, 5, where are we? -5. Okay, 5 and -5 are opposites because they are on opposite sides of 0. They are the same distance away from 0 on the number line. Okay, so opposites are the same distance away from 0 on a number line. Okay, so we have 100 and -100, 2 and -2. What else? Give me some other numbers. 84 and -84. These are opposites because if you look at a number line and start at 0, they're the same distance away from 0 on a number line. Okay, so that's integers. That's how you would graph integers. That's integer opposites. And I'm going to bring our first guest on. Let me clear our screen. And we are going to talk about probability, the good stuff. Hello, guest number 1. Talk to me. Okay, so tell me where you're struggling with probability. Wait, let me make sure I can hear you. Okay. Are you able to hear me?
Yeah.
Okay, there you are. Okay, so probability. Okay, so tell me where you're struggling with it. Is it like if they say, what's the probability? So what's the probability that I'm going to get a heads if I flip a coin? That I'm going to land on heads. Do you know that?
Yeah.
Okay, so what would that be?
1 out of 2.
Yeah. Okay. So there's a head, there's a tail. We have 2 possibilities. And if I want to land on heads, I have a 1 out of 2 chance of doing this. Okay. So you got that. Great. Okay. Have you guys done tree diagrams? Where they say, I have 3 choices of breads. Like somebody wants to make a sandwich, right? They have 3 choices of bread, 4 choices of meats, and 2 choices of veggies. We could put sauces, but whatever. How many possible combinations will they have, right? Have you guys done anything like that?
Yeah.
Okay. How are you with this?
I'm okay with it. It's a little hard.
Okay. So do you want to start here, or is there something specific you want to start with?
We can start here.
Okay. All right. So let's see. What kind of... Maybe I should do something easier. Hold on. Okay, we can still use the same stuff, but Let's see. Okay, so we have 3 shirts to choose from, 4 bottoms, and 2 different types of shoes, okay? So for the bottoms, let's say we have shorts, jeans, skirt, and a skirt. You know what a skirt is?
Yeah.
Okay. I was like, do they have skirts these days? We can have a t-shirt. What other kind of shirts are there? Let's see. Or maybe we should do color. Do you think we should do color? It might be easier. Okay, let's say a red shirt, yellow shirt, blue. And then for shoes, we can wear sandals or sneakers. Okay. So we have 3 possibilities for shirts, 4 possibilities for like your bottoms, and then shoes, we have 2 possibilities. Okay. So there's 3 ways to do. I mean, there's probably more than 3, but you could list them out, right? And say, okay, I could have the red shirt with the shorts, the red shirt with the jeans, the red shirt with the skirt, right? The red shirt with the skirt. I could have the red shirt, shorts, and sandals, or red shirt, shorts, and sneakers, right? Here I'm making a tree diagram, but so it's similar. So you could say red, shorts, sandals, red, shorts, and I'll put SN for sneakers, right? You could put yellow, shorts, and sandals, yellow, shorts, and sneakers. You see what I'm doing? And you can do that for each of them, right? Red, jeans, sandals, red, jeans, sneakers, yellow, jeans, sandals, yellow, jeans, sneakers. Okay, then we could do blue. And we have more, right? We have skirts. So we could absolutely list them all out, right? Each one of these, after a while, you're going to notice a pattern. Okay. And let me show you what that pattern is. So let's keep going with the red. Red. So we have red shorts, sandals, red short sneakers, red jeans, sandals, red jeans, sneakers. Okay. Now red. What's next in our bottoms list after jeans?
Skirt.
Skirt. And then what shoes?
Sandals.
Okay. And red skirt.
Sneakers.
Perfect. And then red, I'll put SO for skirt. And then what shoes?
Sandals.
And then red skirt, what?
Sneakers.
Okay, so how many possibilities are there with just red? 1, 2, 3, 4, 5, 6, 7, 8. You see that?
Yeah.
Okay, and then yellow, they're going to have the same 8, right? Yellow's going to have the same 8. Blue is going to have the same 8. Because all we're doing, it's still the same options. We're just changing that one thing. So we can just, once we list out all of the red, we can just do 8 times what? How many color shirts did you have?
3.
3. So we could do 8 times 3 and we get what? Eight times 3?
24.
Excellent. So we have 24 possibilities. Now, your teacher may have taught you that instead of listing it out, now you can absolutely list it out. And if it's easier for you, you could have kept going, right? You didn't have to stop and say times 3, right? You could have done the shorts and the sandals and kept going, right? And you would eventually be able to count out 24. But when it gets to be a little bit more complicated, like this is a 13, a 14, a 12, right? They don't want you having to count all of that out. So they noticed a pattern. Remember, we got 15, right? Let me delete this so that I'll rewrite it. So remember, we got 24. 3 shirts, 4 bottoms, and 2 shoes. Instead of listing it all out, you actually can multiply all of these together. This is called the fundamental counting principle. Now, I don't know if your teacher showed you this, but this is the same thing as listing it out. Now, what's 3 times 4? What's 3
12.
times? Good. And 12 times 2?
24.
Excellent. You're doing great. Okay. And so this shows that there are 24 possible outcomes, right? For every 3 shirts, there's 4 bottoms that goes with it. So we have to multiply by 4. And then for all of these combinations, there's 2 shoes for each of these combinations. So that's why we're able to multiply them all together and still get the same answer without going through that whole list. Now, did your teacher teach you that you can do you remember if they taught you that you could just multiply it all together, or do they want you to list it all?
She told us that I could do both.
Okay, good. All right. So, so you said probability. Now, have you guys, so we can stay here and do the list options. Have you done anything like independent events? Does that sound familiar? Or compound events?
No.
Okay, good. All right. So then this will be pretty easy. Okay. So let's say you have 3 coins. Okay. So how many possible outcomes can you have? So here's the first coin, the second coin, and the third coin. How many options do you have for this first coin?
3.
Okay, what are your possible outcomes when you flip a coin? You can land. You can land what? Okay, what are those 2?
Heads and tails.
Good. Okay, so we have 2 outcomes for the first coin. What about the second coin? How many outcomes can we have for this coin?
2.
Good. And the last one?
2.
Good. Okay, now, when they say what are the total amount of outcomes we can have, how would you list this? So with these 3 coins, right? The first time I flip all 3, what could it land on? Give me one possibility.
Heads.
For the first one. What about the second one?
Tails.
And the third one?
Heads.
Good. Okay, keep going.
Tails.
Heads.
Tails.
Good. Keep going.
Heads. Tails. Heads.
Okay, we have that up here. So what can we put down here to make it different?
Tails.
Good. Okay, so far we have HTH. I'm going to put my T's in a separate column just so the ones that start with T, just so you can see the difference. Okay, HTT. Okay, keep going.
H. H. T.
Good.
T. H. H.
Good.
T. TH.
Awesome. You're missing 2. One. There's two that you're missing. One on each column. Okay, we know it's going to start with the H for this one, right? And this is going to start with the T. What don't we have yet?
H.
Mm-hmm.
H.
Yeah. Okay, so there's a possibility that all of them could be heads, right? And then what about on the other column?
T, T, T.
Yeah, there we go. Okay, so all of them can land on heads, all of them can land on tails, and then it'll like fluctuate, right? It could be heads, tail, heads, heads, tail, tail. Now, if they say listed, this is what it's going to look like, right? If they say how many possible outcomes, well, you told me how many were on this one. How many possible outcomes were there?
2.
Okay, and this one?
2.
And this one?
2.
And what can we do to multiply? Oh, I just gave the answer. What can we do with these two to find out the total possible outcomes?
Multiply them.
Good. Okay. 2 times 2 is?
4.
And 4 times 2 is?
8.
And look, it's the same amount that we just listed. Okay, there's 4 in this column, and there's 4 in this column. You see? And so we have 8 possible outcomes. So if they say listed, whatever's on your right here, that's what you would list. If they just say how many total possible outcomes, you can say, well, the first event is 2, the second one is 2, and the third coin is 2 possibilities. Multiply it all together, and I have 8 possibilities. Okay. I want you to give me a problem that you may have struggled with. So I don't know if your book is right there with you. If it's not, don't worry, I can fill in the time. But I want you to give me a problem that you were struggling with so that I can make sure I'm like helping you, okay? But so far, are you understanding it?
Yeah.
Okay, so do you need to go get a book, or you know like a problem, or do you have a problem that like you normally would like struggle with?
There's one with like a wheel with 6 sides.
Mm-hmm.
And
Like a
you spin
spinner?
it 2 times. Yeah.
Okay. I didn't draw that correctly. Okay, so you have a spinner, and it has 6, right? Okay, let's see.
Yeah.
Does it have numbers on it?
Yeah.
Okay. And then what else did you say?
You spin it twice.
Okay. And then they want you to find a probability of like landing on like a 6 twice, or a 3 and a 6, something like that.
Yeah.
Okay. So let's say probability of landing on a 6. When you first look at this, how many possibilities are there of landing on a 6?
1 out of 6.
Yeah, right? So the probability of landing on a 6 is a 1 out of 6. Then when I spin it again, on the second chance, what's the probability, or we can leave it here. What's the probability that I'm going to land on a 6 again? The second
1 out of 6.
1 out of 6, right? Now, what's the probability that these things are going to happen one after the other, right? I spin it, I land a 6. I spin it, I land another 6. What would we do with these two probabilities?
Cross multiply.
Not cross multiply. So it wouldn't be cross multiply. What would we do? We would just actually multiply it. Okay, so that, watch this, because I don't have The probability that when I spin something is going to land in the same number twice, it's a very low probability, right? The chances are I'm going to spin a different number in the second try, right? So the chance of this thing happening back to back is very small. So what we do is we multiply this. Now, she may not have called this an independent event, but this actually is what it is. Because me spinning a wheel the first time and then me spinning it again, what I did the first time has no effect on what happens the second time. So me spinning it again, whatever happened the first time is not going to affect me landing on a 6, right? I still have a 1 out of 6 chance. Now, let me show you what the difference is. Say you have a deck of cards, right? How many cards are in a deck?
52.
Okay, so we have 52 cards in a deck. What's the probability that you're going to get an ace on the first time you pick a card out?
4 out of 52.
4 out of 52. Now, what if you don't replace that card? How many cards are now left in the deck? So I have a 4 out of 52 chance of getting an ace when I first pull a card, right? I didn't replace that card. I left it outside the deck and I want to choose a different card. How many cards do I now have left in the deck if I've already taken one out?
4 out of 51.
Yeah. Well, hold on. So how many cards do I have? Don't give me the probability. Just how many cards do I have left?
51.
51. Okay. Now, what's the probability that I'm going to get an ace again? If I already have one ace, how many aces do I have left?
3.
3. So what we would do is this. Okay. So it's 4 out of 52 if I'm pulling the first ace. And then if I want to know the probability of me getting another ace, okay, without replacing that first ace, I have a 4 out of 52 chance the first time. The second time, I don't have that ace anymore, so it's a 3 out of, and now I only have 51 cards, okay? Now, I don't know if you got that far with dependent events. Does this look at all familiar?
Yeah.
Okay, you did do this?
Yeah.
Oh, perfect. Okay, we're on the right track. Okay, so good. I want to make sure that I was helping you. So let's do that. Okay. So what you're doing is called compound events, right? 2 or more events that happen, okay? So just like a compound word, compound events are 2 or more events. And we call these events either independent or dependent events. So a dependent event would be just like what we did. When we don't replace the card, what happened here for this second one, this 3 out of 51, this probability was based on what happened with the first one, right? If we replace the card, what's the probability that I'm going to draw an ace? If we put the card back in the deck, now how many cards do I have? So we drew a card and then we put it back in the deck. So how many cards do I have?
52.
And then how many aces do I have?
4.
Yeah. Okay. So you see how it's independent? So in this one, I had a 4 out of 52 chance of pulling an ace. And then I did it again. I put it back. So now I'm starting like as if it's brand new. Now I still have a 4 out of 52 chance for my second one. Okay, and you would multiply those two together. For the right one, that 351 was it was affected by me not replacing the card. Now I only have 51 cards. Now I only have 3 aces. Okay, so that's the difference. Let me give you some more examples. Okay. So I want you to tell me, before I give you an example, I just want you to tell me where it would go. I have a bag of marbles. I'm sure they gave you like lots of marble examples because for probability, they just love marbles. Okay, so I have a bag of marbles. I have 10 marbles in a bag. 5 are black and 5 are red. Okay, 5 are black, 5 are red. I take out one marble, a red marble. So let me just write this down. Hold on. Okay, so there's 10 marbles, 5 black, 5 red. All right, I take out a black marble, and then I put it back in the bag, and I take out another black marble. Would this be an independent event or a dependent event? So I take out a marble, a black marble, I put it back in the bag, and I take out another black marble.
Dependent.
Okay, why you say dependent? So first, how much, what is the probability of me getting a black marble?
5 out of 10.
5 out of 10, okay? Now, the second time, right, we want to know, is what I put here dependent on what happened with this first pick? So I picked it, and then I put it back in the bag. Is that going to change my probability now? How many marbles do I have?
10.
Mm-hmm. Okay, and then what's the probability of getting a black?
5.
Yeah. Okay, so is that independent or dependent?
Independent.
Independent, good. So this example, me replacing and putting it back in the bag, me replacing that marble made it independent, okay? So if I didn't replace it, what would that be? Independent or dependent if I didn't replace it?
Dependent.
Good, okay? So not replacing is dependent. Awesome. Okay, so that is a compound event. Let's see. Spinning a spinner and landing on a 6. So here's the 2 events that can happen. Okay, I spin let's do dice. Okay, so I roll a dice and I land on a 6, and I flip a coin and land on heads. Okay, so what is the probability that I'm going to get a 6 when I roll the die? So 4 dice, what's the probability that when I roll the die, I'm going to land on a 6?
One out of 4.
How many sides are there on a dice? So remember, it's like a cube.
6.
Good. Okay. So there's 6 sides, and so 1 out of 6. Okay, because there's only 1 6 in a dice on the dice. There's only one number 6. Okay. And flipping a coin, what's the probability that I'm going to land on heads?
1 out of 2.
Good. And what am I going to do with these 2 fractions?
Multiply them.
Excellent. And 1 times 1 is?
1.
And 6 times 2 is?
12.
Woohoo! Awesome. Okay. So is this an independent event? Is me flipping a coin going to change after I roll this dice? Does one affect the other?
No.
No, right? These are two independent events. If I want to roll a die and flip a coin at the same time, I have a 1 out of 12 chance of landing on a 6 and landing on heads. Okay, 1/12. It's not bad. We should try that one day. 1 out of 12. Okay, so good. It seems like you're catching on and understanding the difference between independent and dependent. I'm going to give you some more examples, okay? So let's give you a spinner with 8. Possibilities. Now, I know they make it a little bit complicated by doing things like this. Okay. What is the probability of landing on a 1 and then landing on a 1 again? I think they actually, I think they write it like this: land on 1 and then land on 1 again. Something like that, right? Do you remember seeing that? Okay. So I think that's how they usually write it. Okay. So would this be independent or dependent? So I spin a spinner. The first time I land on a 1, I spin it again. And the second time I land on a 1.
Independent.
Very good. Why?
The first one doesn't affect the second one.
Yes, good. Okay, so tell me the probability of landing on the first one.
One out of 8.
Okay, so how many 1s are there?
Oh, 4.
Okay, good. 4 out of 8. And then the second time?
4 out of 8.
Good. And what am I going to do?
Cross multiply. Just multiply.
Good. Okay. And 4 times 4?
16.
And 8 times 8?
64.
Okay. Can we simplify this fraction? What can go into both 16 and 64?
4.
Mm-hmm. Good. Okay. 16 divided by 4?
4.
Good. It's a little bit trickier. 64 divided by 4. Do you know that one?
Is it 16?
Yeah, good. Okay, what can go into both of those now? 4 and 16.
2.
Okay, 2, something a little bigger.
4.
Good. And 4 divided by 4?
1.
And 16 divided by 4?
4.
Okay, so I want to explain something. So I think what's happening is, do you see your teacher might be cross-canceling? Okay, like when they see a number that can be divided into both 8 and 4, what number can go into both 8 and 4?
4.
Mm-hmm. So 8 divided by 4 is?
2.
And 4 divided by 4 is?
1.
Okay, and then we can do the same thing with these two, right? 8 divided by 4 is 2. And then multiply straight across. Does this look similar to what your teacher might have done?
Yeah.
Okay, so this is called cross-canceling. It's just a shortcut for multiplying fractions. So if you struggle with cross-canceling, it's just the same thing as multiplying these fractions straight across and then reducing them at the end. It's the same thing. It's a shortcut. So you get there faster, right? We have 1/4 over here. We eventually got to 1/4 over here. So how are you with cross canceling? Do you feel better cross canceling, or would you prefer to just multiply straight across?
I feel better cross canceling.
Oh, okay. Then that works. Okay. So I just wanted to make sure when you kept saying cross multiplying, I was like, I think she means cross canceling. Okay. So then let's do cross canceling then. Okay. Because that'll make your life a lot easier. Also, beforehand, what could I have reduced this to? This 4/8. 4/8 is the same as what?
1/2.
1/2. So you actually, from the start, could have just reduced those fractions and got to 1/4, and you wouldn't have needed any cross canceling. Okay, so let's try that again. So what's the probability of getting a 2 and then a 1? So what's the probability of spinning the spinner and then getting a 2 and then a 1?
4 out of 8 and 4 out of 8.
Good. Okay, which is the same as
1/2.
good. Okay, and what are we going to do with these two probabilities?
Multiply them.
Excellent. And we get
1/4.
yes. Okay. All right, I'm going to give you another one, but you let me know if there's anything else you want to go over that I haven't got to yet, okay, with probability. All right, we have our bag. All right. Oh, that was supposed to be a bag. Okay. We got marbles in here. Six, okay. 3, 4. All right. So, what is the probability of getting green then blue? And I'll put no replacement. Okay, so try that out. So we have these marbles in a bag. What's the probability that you're going to pick out a green and then you're going to pick out a blue? When we say no replacement, it means once you pick out that green, you're not putting it back into the bag before you pick blue. Okay.
So would it be 4?
What's 4?
The green.
Okay. So the probability of green is 4 of choosing green.
Four out of 10.
Excellent. Okay, keep going.
And the blue would be 3 out of 10.
Okay, and then what?
And we would multiply them.
Okay, and you get what?
12 over 20.
10 times 10. Oh, wait, hold on, let me. Okay, is there anything we can do to cross cancel? Can 3 go into 10? Is there any number, I'm sorry, is there any number that can go into 3 and 10?
No.
Okay, what about 4 and 10?
2.
Good. 4 divided by 2 is?
2.
Okay, and 10 divided by 2?
5.
Good. And 2 times 3?
6.
And 10 times 5?
50.
Excellent. We can reduce a little bit more. So this doesn't always get rid of reducing, but okay, now pause. How would this be different if we replaced the green one? So what's the probability that the first time I'm going to get green?
Four to 10.
Good. Now I put that green back. What is the probability that I'm going to get a blue?
3 out of 10.
Okay, so look at what you had before when we didn't replace it, and look at what you have now when we replace it. Which one is correct? So on the left, we replaced it, and we put it back in the bag. And on the right, we didn't replace it, but you have the same numbers, right? 4 out of 10 and 3 out of 10. So let me put that back. Which one is correct?
The replaced one.
Okay, how do you know it's correct?
Because when you pull one out, it's not missing one.
Mm-hmm. Okay, so what do I need to change with the one that's not replaced?
3 out of 10.
Mm-hmm. It's going to become what?
3 out of 9.
Excellent. Okay, so just be careful. When you see those words, did not replace, or they left it out, right? They didn't, as long as it doesn't say I put it back in the bag or I replaced it, then you know that it's going to be one less that's in the bag. So it's going to be 3 out of 9. And let's see, is there anything I can do when I look at them? Anything that goes into both 4 and 9? Oops.
Four.
For 4 and 9?
Oh, nothing.
Nothing, right? And we already know nothing goes into 10. So we just multiply straight across. 4 times 3.
12.
And 10 times 9.
90.
Excellent. Okay, and then you can reduce it. 2 goes into both of these, and you'll get, that is not right, 6 over 45. Okay, 6 could have gone into both of those. Eventually you'll get 2 15ths. Okay, so over here you got 56, right? Which was 3 over 25. Okay, so you had a 3 out of 25 chance of getting a green and blue when you replaced it, and when you didn't replace it, you had a 2 out of 15 shot to get a green, then blue. Excellent job. Okay, let's try it again. Do you feel like I covered everything? Is there anything that I haven't covered yet, or anything you still wanted to go over?
I think you got everything.
Ooh, yay. Okay, so let's do this last one. So I want you to give it to me with replacement and without replacement. Okay. So probability of pink, then yellow. That's with replacement, and that's supposed to say without replacement, but that O is very close. Okay, it's the same thing. So probability of pink and then yellow. Okay, tell me what you got.
2 pink out of 10.
Okay.
And 1 yellow out of 10.
Mm-hmm.
and you'll multiply them.
Mm-hmm.
You'll reduce the 2 and the 10.
Good.
So 2 divided by 2 is 1, and 10 divided by 2 is 5.
Excellent.
And you'll do 1 times 1 is 1, and 10 times 5 is 50.
Woohoo! Awesome. Good job. Okay, so that was with replacement. And with replacement, is that, do you remember if that's independent or dependent?
Dependent.
So when I put it back in the bag, does that change what this probability is going to be when I pick this pink and then I put it back in the bag?
No.
No. Okay, so what should it be?
Independent.
Independent. Perfect. Now I'm not going to replace it, so tell me how I'm going to change this.
The pink would be 2 out of 10.
Excellent.
And the yellow would be 1 out of 10. Oh, 1 out of 9.
Good. Nice catch.
And we'll multiply and do 2 times 1 is 2, and 9 times 10 is 90.
Excellent. Are we done? Can we do anything else?
I could divide by 2.
Good. Okay, what do you get?
1 over 45.
Excellent. Hey, you have a better chance with it not being replaced. But good job. Good catch on that 1 out of 9. I don't think you said she didn't use those specific words, right? Independent and dependent.
Yeah.
Okay, so don't worry about knowing the difference between independent. You do know the difference, but as long as you know, like, okay, if I don't replace it, now I have 9 left, so it's a 1 out of 9 chance. Now, what happens if it was yellow for the first one? I just want to show you something real quick. So if it's yellow for the first one and yellow for the second one, how would my probability change?
It would be 1 out of 10.
Uh-huh.
And would it be 0 out of 9?
Yeah. Nice job. So you would have a 0 chance of that. Okay. Good. Awesome job. Woo, woo, woo. Excellent. So how are you feeling about it?
Much better.
Yay. So happy to hear that. Awesome. Okay, let me know if you need anything else, okay?
Okay.
Alrighty. That was awesome. Okay, so yeah, probability. I want to say you see it in 7th. You may see it a little bit in 8th. You're definitely gonna see it in algebra in high school again. And they're gonna use those terms: compound events, independent, dependent, fundamental counting principle, all of that will show up again. Yeah, so great job. If there's anyone who needs assistance, this is what you're going to do. You are going to look at the Google form in the description of this video. You can submit your questions on that form, and then you can also call in, and I will connect you so that I can help you. All right. Great job, caller number 1. So we're going to take a quick break and be right back. There we go. Hello and welcome back to More Math. If you're just tuning in, welcome. Okay, so as it says on the bottom of the screen, if you have any questions at all, you can just submit that your questions in the Google form in the description of this video, as well as phone in and get the help you need. So just to recap tonight's show, tonight we had a special guest caller who needed help with probability, and so we spent the bulk of the time on the fundamental counting principles as well as independent and dependent, and she did amazing, feeling more confident as she goes into school tomorrow. And we also talked about integers. Okay, so just to recap, integers were positive, negative, and zero numbers, right? Positive numbers, negative numbers, and the number zero, which is neutral. Okay, and so if we were to plot a point on the graph, like the number 3, and we say graph the number 3, you would just draw a circle, fill it in where the tick mark meets the number line. Okay, and that's how it would go. Okay, once again, if you're plotting the number -3, you would draw the line. And also, we talked about opposites. 3 is 1, 2, 3 spaces away from 0 on a number line. And the number -3 is 1, 2, 3 spaces away from 0 to the left of 0, right? So these are opposites because they are the same distance away from 0 on a number line, okay? So that is opposite. These are integers. And that is that. So thank you so much for tuning in. Tonight has been so great. We will be back. Not sure how many more we will have. Maybe it's the end of the school year. We'll get back to you on that. But we'll be back next week. That we do know. So we will be back next week with more math at 8 p.m. Eastern Standard Time. If ever you have a question, submit that form. And then on Wednesdays, we will be here to answer your question. So that is another episode of More Math. I will see you next week. Bye.